In today's video, we're going to start talking about the periodic table. So we've been learning about atomic structure and how electrons are organized in atoms, and we've actually already seen how atomic structure is related to the periodic table. So we're going to start to get into some of the things that the periodic table can tell us, other than just like the numbers that are listed on it. So the way the elements are organized is intentional and useful, and there are lots of trends on the periodic table for like, as you go across, this particular property tends to get higher or lower. So before we can talk about that, we need to talk a little bit about the periodic table itself before we can kind of bridge that gap between the periodic table and atomic structure. So we know what the periodic table is, we have seen it, we have used it. The periodic table as we know it today was developed by a man by the name of Dmitry Mendeleev. He is often referred to as the father of the modern periodic table. He is far from the only person who tried to find some sort of organization to the elements, but he is the one we give most of the credit to for the periodic table that we have today. Granted, his periodic table did not look anything, really, did not look very much like the one that we use today, but it's the basis for how things are organized. So what Dmitry Mendeleev did was he arranged the elements in order of increasing mass, which is not quite how we do it today. Today we use atomic number. For the most part, the order is the same, but there are a few places where the mass actually goes out of order with atomic number, and we've found that atomic number is much more indicative of the properties of an element, that things fit better when it's organized this way. At the time, they didn't fully understand the concept of atomic number yet, so mass was the data that they had to work off of. They knew that different elements had different masses, so they organized it that way. And the thing that really set Mendeleev's version of the periodic table apart from his peers at the time was that Mendeleev was single-mindedly focused on making the patterns work, that he saw these patterns, that certain elements seemed similar to other elements, and other people saw like, oh, well, the trends aren't perfect, like such is life. But Mendeleev really felt like the trends should be pretty close to perfect. So what he actually did in his version of the periodic table was he left gaps in his table where he predicted there was an element we hadn't discovered yet. And he was right about quite a few things. And even going so far as to predict properties of elements that we had not yet discovered based on trends in his periodic table, and a lot of it matched up pretty well. So this was what set him apart from his peers, that other people were trying to make periodic tables based on the assumption that we had discovered all of the elements that there were to discover on Earth. And Mendeleev realized that if there were other elements out there that we had not yet discovered, that would fill in these holes, it would make the trends work. So that is where we kind of get the general organization from. Today, in our current version of the periodic table, there are lots of different ways that we can kind of categorize elements. So we're going to talk about labeling some of the different parts and pieces of the periodic table. A few things to be aware of in sort of general terms. The periodic table gets its name from the periods of the table, which are the rows. So when we refer to a period on the periodic table, we are talking about a row, a horizontal line. So the first period of the periodic table is the top row, which is comprised of just hydrogen and helium. So the first period, or period 1, would be hydrogen and helium. There are 7 periods in the periodic table. Copy. Actually. And then we also have groups or families, which are the columns, or the vertical lines. So the groups have a variety, unfortunately, of different ways that they get labeled. I'm going to be using sort of just this outline of the periodic table to block off. Actually, I want to move that down a little bit. Block off different sections and identify different parts and pieces, and I'll be copying this over a few times. So the periods are our columns. So period 1 is hydrogen and helium, and then we have 2, 3, 4, 5, 6, 7. Note that this little section down the bottom actually belongs, like we talked about with electron configuration, tucked in between these two pieces. So this really belongs here. That is part of period 6, and then this is part of period 7. So they're not additional periods at the end. It's 7 periods in the periodic table. So these are our period numbers. So for groups and families, those are going to be our columns, so we're going to number them across the top. And again, there are a few different systems for numbering the families, which is a little bit unfortunate. The sort of simplest one is literally just numbering left to right all the way across, which gets us to 18. You'll notice that we skip these. This section of the periodic table doesn't come up very much in chemistry, to be perfectly honest, so it gets kind of overlooked in a lot of aspects. So one way that we can number the groups is literally just numbering them left to right, 1 through 18, in that main portion of the periodic table. And an alternative numbering system is a little weird, but usually more commonly used. Kind of separates this portion of the periodic table from the S&P blocks, and refers to the S&P blocks as the A blocks. So we have 1A, 2A, and then we jump over to the P block for 3A. 5A, 6A, 7A, and 8A. And then in the middle section, the D block, these get referred to as the B families, and for whatever reason, we start with 3B here. So we're going 1, 2, 3, I think. It's still continuing. 4B, 5B, 6B, 7B, and then 8B is actually 3 columns. And then we circle back to 1 and 2. So you don't need to memorize the weirdness in the B section. These numbers with the B's don't get used very often, but the 1 through 8A nomenclature does get used pretty frequently. So those are a couple different ways of notating or labeling the groups and families. Some of the families also have special names. So back to the pen. So group 1A is known as the alkali metals. Group 2A is known as the alkaline earth metals. Group 7A is the next one to know, is known as the halogens. And then 8A we've mentioned before is the noble gases. So just to kind of write those in here, this column, excluding hydrogen technically, is the alkali metals. This is the alkaline earth metals. And then over here on the right, we've got the noble gases farthest to the right, and we've got halogens right next to them. Other than that, if you want to name a family, we either refer to it by its number or you can refer to it by the top element. So for instance, group 6A, the top element here is oxygen, so you could refer to that as the oxygen family if you need to refer to that column. But those are the families that have specific names that are likely to come up. We do also have names for the rows of this weird little block down here. The top row here is referred to as the lanthanide series. The first element in this row is lanthanum, so that's what it's named for. And then this one is known as the actinide series because the first element in this row is known as actinium. So those are some particular parts and pieces that you should be aware of. There are also other ways that we can subdivide or categorize elements on the periodic table. So let's see, how do we want to do this? Take another version of this fellow. We've already talked about the SPDF situation, so that really puts helium in the S block. The P block, the D block, and the F block. Similar subdivisions, but different names for the blocks. I'm sorry we have so many names, but we do. Welcome to science. These, the S and P blocks together are commonly known, where do I want to put this? Over here, as either the main group or the representative elements. The D block in the middle is also commonly known as the transition metals. That's one that you will hear a lot. And the F block you will often hear referred to as the rare earth elements or rare earth metals. What else do we have? And then last but not least, the other way that elements are often categorized according to their position on the periodic table is by whether or not they are metals. So there is sort of this diagonal line, sometimes referred to as like a staircase because it's a zigzaggy situation, that goes down the periodic table right about here or so. So this, just for reference, is boron. And the elements that lie around this staircase are kind of the dividing line between the metals on one side and the non-metals on the other. So metals in general are elements that tend to be hard. They are often shiny in appearance. They are usually solids except for mercury. They have high melting and boiling points. And they're generally good conductors of heat and electricity. And the metals are pretty much the whole left side of the periodic table. So most of the elements we have, really, are metals. Is everything to the left of this sort of dividing staircase, except for hydrogen. Remember that the rare earth elements really belong in between the S and D blocks, so those are also all metals. So the organization of the periodic table is such that elements with similar properties end up close together. So that's where we're seeing all of the metals are clumped together on one side of the periodic table for the most part. Non-metals are generally softer. Appearances vary pretty wildly. They have lower melting and boiling points. And they're generally poor conductors of heat and electricity. So the nonmetals are everything to the right of that dividing area, plus hydrogen is also considered a nonmetal. And that area in between is what we call the semimetals or the metalloids. I don't care which name you use, I usually go with metalloids. And these are elements that have properties somewhere in between. So all of these are our metalloids in that purple area. So I can probably fit that in there. And no, that's hard to read. So these are just some of the different ways that we can categorize elements according to, in the last case, their properties, whether they're a metal or a nonmetal, and in the other ones, just kind of grouping them together according to where they fall in the periodic table. So depending on the context of what you're talking about, sometimes one name is more or less useful than another. So you should be more or less familiar with the different ways that we can call things. And this will allow us to talk in more depth about the periodic table and how it relates to atomic structure.